Hello, all. Good evening. Thank you for joining us. Jana, hope you are able to see my screen.
Yes, Navneet. I'm able to see your screen. Are you able to hear me?
Okay. Yes, yes, yes. Okay, Jana, I'll
Okay.
continue. Thank you.
Yeah.
Okay. Hello, all. Good evening. Thank you for joining us. I'm very excited about today's session. Welcome to the machine learning series as part of Azure developer community. In this session, you will learn feature engineering using unsupervised learning techniques. Thank you, Ashwin, for sharing your knowledge with our community. I will give short intro about our community and have some updates. Then I will hand it over to Ashwin. So from Azure Developer Community, what we do. So we regularly conduct meetups, mostly third Saturday in-person events. So we conduct based on different categories like data, artificial intelligence, developer day. So tomorrow also we have event. And other than that, we conduct some certification study jams where we give inputs to how you can prepare the certification and what are all the best ways to prepare it. So that also we do. And earlier we was conducting some podcast and all. If you are interested to join our meetup, please follow us in meetup, Azure Developer Community Chennai. And I just want to give a few event updates. On June 24th, we have fastest coder hackathon from Microsoft Azure. So you can follow this and you can join. And the next event I want to give update. It's a Kubernetes Community Days. It's happening on 22nd July. It's an in-person event in Chennai. Thank you. I will hand it over to Ashwin.
Uh, so, thank you, Navneethan, for giving me this opportunity. And I would like to thank the Azure developer community for giving me this opportunity in order to provide my or share my knowledge and insights on this topic. So, I'll share my screen right now. So, is my screen visible right now?
Yes, Ashwin, go ahead.
Okay. So, good evening to one and all present here. So, this talk is going to be about feature engineering using unsupervised learning techniques. So, in the session is going to be broken into two parts, and in this session we are gonna discuss about unsupervised learning techniques, especially about K-means algorithm, and what are the insights and how does the algorithm work, as well as how we could actually scratch, how to write the code from scratch as well. So before going to the algorithm, I would like a short brief of myself. I'm Ashwin Balasubramanian. I have completed my BA Computer Science in Loyal Icon College of Engineering and Technology. My I have been a part of multiple internships through several companies as well as government firms such as the National Institute of Wind Energy, Indian Meteorological Department, as well as several companies as a research engineer as well as a data scientist. I have published several papers on the domain of computer vision as well as natural language processing, and here I am in order to share my knowledge in this topic. So going to the topic. So what is unsupervised learning? Machine learning has been primarily classified into supervised learning, unsupervised learning, as well as reinforcement learning. So we will be focusing mainly upon unsupervised learning in this session. In unsupervised learning, the data or the inputs that we are going to give to our algorithm is going to be an unlabeled data. So each records or each data value or data points of our data wouldn't be classified or wouldn't be given up a label while we are passing it to the algorithm. So the algorithm is going to take mainly the features or what and all the attributes of the data rather than directly mapping it into a label. So here is a clear example of how we can actually visualize unsupervised learning in layman terms. So at the left hand side, we have an input raw data. It is a collection of fruits, a multiple of oranges as well as an apples. While we are passing it into our unsupervised learning algorithm, based on the features and how similar they are, the clusters are segregated or they are created based upon how similar the features of every data points are. So the output in this respective images, like we have based on the color as well as since it is going to be apples and oranges, based on the similar features, they have been segregated into clusters. And unsupervised learning could be further classified into clustering and association. So here we will be in this entire section, we will be focusing mainly upon clustering, especially the K-means algorithm. So coming on to the clustering. Clustering in layman terms, we could say it is a technique that seems to find the similarity between every data points and group and cluster them to a particular cluster of similar features. So the similarity which is being detected or which has been figured out between every data points. So based on that, we would be uh, creating a cluster for every similar features. And coming to examples of clustering in real time. So let us say that we have a wardrobe of lots of t-shirts of different sizes. So while we are actually trying to make use of it and segregating it according to our sizes, we will be segregating based on what kind of size it is, whether it is a small size or medium size or larger size. So based on the size, we will be actually allocating it, and we will be separating those t-shirts. So based on what size it is, we are actually separating it. The another example that we could actually make use of is the customers who are actually coming in order to buy groceries in a market. So let us say that several customers in a market might have interest, like they wanted to buy just the dairy goods such as milk or curd, or some might have certain interest in order to buy um, some snacks or something else, or some other people would have some other necessities. So based on what kind of interest they have, the customers could be segregated, or they could actually be clustered into what kind of interests they have. So with these interests, the marketing team or the marketing strategist might have an idea in order to what kind of products that they need to focus upon. So with this data, they will be able to understand and in what kind of way that they need to propagate their entire business strategy. So coming to the K-means clustering algorithm. So K-means as is one of the clustering algorithm that is actually pretty much effective in several parts of the data as well as in several use cases. So we will be discussing upon on what kind of use cases that they will be pretty much useful. So K in the term K means seems to define the number of clusters or the number of groups that are created after the algorithm is iterated. So the K-means algorithm will be able to partition or will be able to generate clusters of the number of clusters that we are going to give it as an input in the initial part of the algorithm as well. So how does it actually segregates or how does it actually creates the clusters? So that will be discussed upon in the upcoming slides. So let us discuss about how the basic algorithm or how the structure or how it is actually derived. So the algorithm initially, as discussed before, we will be defining the number of cluster heads that needs to be created. So let us say in our above example, we have an 2D plane. For more of simplification purposes and in order to understand the algorithm more clearly and effectively, we are actually declaring two cluster centers, which are defined as seed 1 or seed 2, as well as we are having a data set which contains two attributes or two features. So if a data has two attributes, they could actually be visualized easily in a 2D plane. So that is what I have done here. So initially we have selected a value for k. Let us say I have chosen the values 2. So I have chosen two cluster centers. The step one involves randomly selecting the cluster centers. How we could actually create? How we actually could select the cluster centers? Initially, at the initialization step, the cluster centers must be chosen among the datasets in a random manner. We could actually choose them in a sequential manner. Yeah, that could work. But choosing a random one would, there is a possibility of reducing the number of iterations in order to reach the optimized model or the optimized clusters. So we move on the approach of choosing the cluster heads randomly. So in the above example, I have chosen the clusters or the cluster heads as 650 and 200 in order to initialize the algorithm. So coming to the step two. Here, I will be, as discussed before, clustering mainly involves finding the similarity between every data point. So the metrics that I use here in order to quantify the similarity between the data point as well as the cluster center would be the Euclidean distance, which everyone would have learned it during our analytical geometry lessons in our school days. Since it is going to be of a 2D plane, as in the previous example, we could actually use, in order to find the distance between the data points, we could use the formula of root of x1 minus x2 the whole square plus y1 minus y2 the whole square. So the similar formula applies for n dimensions or n features as well. So here I will be calculating the distance between the data point as well as the cluster head or the seed that we have randomly initialized. So I will be finding out the distances between the data points as well as the cluster center. And once I have figured out the distances, the magnitude, I will be finding out the minimum distance or for which cluster head the object or the data point is pretty close to. So in order to figure it out, I'm using Euclidean distance here. So once I have figured out all the distances and all the how for which close or for which cluster head the data point is pretty close into, after this step, I will be grouping the data points to that clusters or cluster heads. So here in this step, let us say that I have a data point which lies around in the range of 0 comma 500. So if I calculate the distance from that point and to that seed 1 as well as the seed 2, I'll be figuring it out for which point that the cluster head is pretty close. So once I find out it is close to seed 1 or it is close to seed 2, I would be clustering it to that group. So this process happens for all the data points, but the distances won't be calculated between the cluster heads, but would be calculated between the cluster head as well as the data point. So that is an important point in order to be remembered while we are implementing the algorithm. So coming to the step 4, which is more of an important portion in our algorithm. In k-means, after every iteration, the cluster heads or the centroids would be initialized or would be updated based on the points that are grouped. How would we actually update the cluster heads? So the cluster heads would be updated by taking the mean or the average of all the features that belong to that cluster. So since our example mainly handles with two-dimensional data or two features, two attributes, we have two cluster centers. So every cluster is being denoted with the color of red as well as blue. So the red clusters or the red data points, the mean of every features would be of that cluster will be computed, and a new cluster center or the centroid would be calculated. So this process happens at the step 4. So the steps that we have discussed until now, calculating the distances between the centroid as well as the data point, and assigning the data points to that particular cluster, as well as updating the centroids. this would happen in every iteration or occurs iteratively. You could ask me, when will we actually stop? When will we actually stop the algorithm? When will we actually say that the algorithm is pretty optimized for our particular or current data set? The answer is pretty simple. The cluster heads would be there are actually pretty there are two methods in order to end the training of the algorithm. The two methods which are discussed are either we could actually set up a limit, like we could actually set up the a number of iterations that needed to be carried over, or there's a more of a better and an optimized method that involves figuring out whether the cluster heads are repeating or not. So let us say let us take the current example as well. The updated centroid is of the centroids, the values 708.9 as 21 and 214.2. After the second iteration, if both the cluster heads seems to repeat, then there is no point of doing the entire process again. So instead of that, we can actually we can simply end the process. And now coming to how we can actually implement the algorithm from scratch. Yes. So before going in depth of the algorithm, I would just like to recap of what and all the steps that are required in order to implement. So initially, we need to randomly set. One second. Yeah. So initially we'll be randomly setting the number of cluster heads. That would be the initial step. And before that, we'll be setting up the number of cluster heads or number of clusters that needs to be created. So we have two variables that needs to be initialized before we are going into the iteration. The second is calculating the distances between each data point as well as cluster heads. So that is done using Euclidean distance in our example. And another step would be assigning every object to the closest cluster. So that is done by finding the minimum distance and clustering it to that particular cluster for the cluster head, which is minimum of distance. The final step involves updation or updating the current cluster heads by finding the mean of all the attributes of that particular cluster. So these are the steps that needs to be carried out. So now let us move towards the implementation of K-means from scratch. So in order to implement K-means, I have made use of Python and Jupyter Notebook for simplicity purposes. And for scratch, I have made use of NumPy package in order to carry over numerical calculations as well as computations. I have made use of random package in order to initialize random values for a random initialization as discussed in our first step, as well as math package in order to in order to implement the Euclidean distance method, as well as matplotlib, the visualization library present in Python that will be using here in order to visualize our current random data set, as well as visualizing our data set at every iteration. So now let us start. So here I have declared a code cell for importing all the packages. So I have imported NumPy, random, and I have renamed it as RD, and I have imported the math library as well as matplotlib. So now let us now here in our example we will be uh, for simplicity we will be actually handling data of two features. So we will be randomly generating our data set in our example. So for our practical purposes, I am planning to create a data set of size 50 data points. So I have declared a variable with named data set size that holds a value of 50, and I'm creating a data set of 50 data points which contains two attributes each. So in order to create the data set, I have made use of NumPy array in order to convert the nested lists into an date array data type, as well as I have made use of random library here as well in order to use the method randint. to generate the data points randomly. The parameters which I have given here for the randint method is the lower level and the upper level. So the numbers or the integers that will be randomly generated will be within the limit within 0 and 100. So I'll be creating 50 data points. Each data point would be having two features, and those two features would be randomly generated. So let I will just execute the code, and so this is the output which I have received here. And if I wanna if I want to calculate, like, in order to know the shape of this shape, it would be of 50 records, and each record would have two features each. And the metrics which we have discussed here, which is the Euclidean distance, I have created a method in order to calculate and or compute the Euclidean distance. Since our data set is gonna be it has two features, simple the basic magnitude between 2 points formula could be used here, which is root of x1 minus x2 the whole square plus y1 minus y2 the whole square. So every term, the x1 minus x2 the x1 minus x2 the y1 minus 2, those attribute to the to the square of the difference of every features. So with this formula, I will be able to find how similar they are in accordance with every features in that data set. So I have used math.sqrt package in order to do the square root of the entire value which I have proposed here. And here I have I'll just run the code once again. So this is the sample data set. So I have used scatter plot in order to plot all the data points individually. So we will be able to understand how the data set is pretty random and how we could actually cluster it or group it accordingly. By this image, we could actually figure out, or we could understand that by intuition or by seeing the data points within 200 to 600 could form a cluster, 60 to 80 could form a cluster, and something within 40 to 60, which is in the x-axis, could form a cluster. So by intuition, we could actually figure out that since these data points are pretty close, then we could actually form a cluster and so on. Now let us try implementing the K-means algorithm for this data set. So I have actually summarized the algorithm in these 4 steps. So so that we will be able to implement the algorithm in a better manner. So initial step would be the random centroids selection. As discussed in our presentation, the initial cluster heads or the cluster seeds or the centroids that we will be initializing at the first step must be among the data points that are present. So so here also I have used the random package once again in order to choose the point randomly, in order to remove bias. So this is a method which I have used in order to end the iteration. As discussed in our presentation, in order to conclude our iteration, either we could set up the number of iterations that to be declared, or we could actually figure out whether the cluster heads or the centroids are repeating. So in order to figure out whether the previous centroids or cluster heads are the same as the newly generated ones, I have created a method here named isClusterHeadsSame. So the parameters for the method is previous cluster heads, comma current cluster heads. Since our cluster heads is gonna be of 2 dimension, we could actually sort and we could do a list comparison or nested list comparison in order to figure out whether the elements within the nested lists or within the list is same or not. But that is actually carried out by the equality operator here. And I have also created a method named plot underscore data, which takes parameters of the data points, the cluster head, as well as the color which I need to assign to that data set. So here I have once again I have used the scatter plot, and as the algorithm moves, the initial step must be choosing the clusters. So or the number of clusters for which I need to train our model. In our example, for our training purposes, we are using the number of clusters as 3. And the cluster heads, as mentioned earlier, like few moments back, that the cluster heads must be randomly generated in order to initialize the algorithm. So here, once again, I have used my random package, and sorry, since I'll be picking a random point among the data set, I'll be using randint, and the lower limit will be will be 0, and upper limit will be the number of elements or the data set size, which is 50, as discussed here. So here, what we'll be doing is we'll be picking up 3 cluster heads randomly, so that we'll be able to initialize the algorithm. And coming to the main aspect or the main component of our algorithm, which is the iteration or the iterative loop. Here, this loop I have developed it as an infinite loop. So I have used while true in order to execute the loop infinite or n number of times. I have declared a variable iter underscore in order to denote the number of iterations that it takes in order to reach the optimum level. And as discussed in the presentation, like once we have figured out the cluster heads or the centroids, we actually had an idea stating that we need to be grouping the clusters to that cluster heads based on the distances or the metrics that will be used in order to compute. So in order to group them to the particular clusters that will be generated along the way, I have created classes dictionary. As everyone know, a dictionary has a key stores data in the form of key value pairs. So the key will be the index or the cluster head value, and the values would be a nested list or would be a nested data set which contains the data points that to be grouped to that particular cluster head. So this would be the empty dictionary or the empty classes that I am generating in this occasion. So I'm looping it until the number of clusters that to be created, which is 3. And I'm generating a dummy classes variable. So for every key, I'm actually creating an empty list in order to push in all the data points which are closer to that cluster head. And before going in depth, uh, since in key value pairs and classes, as I mentioned, the cluster heads would be given an index value, as I mentioned earlier. So let us say that we have 3 cluster heads. If we are having 3 cluster heads, and the indexing or the index values which would be given for every cluster heads would be 0, 1, and 2. So 0 belongs to the first cluster, 1 belongs to the second cluster, as well as 2 belongs to the third cluster. and and this loop for point in data. So we are using this data, this loop in order to iterate among all the data points of our data set, calculate the Euclidean distance between the data point and all the cluster heads, finding the minimum among them, and pushing the data point to that cluster, which is in our code is that classes dictionary. So the distances which I have declared in this code cell, distance is equal to Euclidean distance of point comma cluster head. This method will be able allow me to create or to calculate the Euclidean distance between the point and the cluster head for all the cluster heads that we have generated right now. So in our first loop, the cluster heads that we have generated will be random, and after appending all the distances in a list, I'll be finding the minimum among the distances which we have computed or calculated until now. So the distances which denote the list of the magnitude between the cluster heads as well as cluster heads and that particular data point, I'll be finding the minimum using the minimum function, and I will be finding out at which index the minimum is present. So let us say that in our example we are having three clusters. So the distances list would have the values of 12 comma, just for an example let us say it has 12 comma 2 comma and a90. So the minimum among these three values would be 2, and we finding the index of it would correspond to the index of the cluster head. So 12 would be the distance between the cluster head 1 and that point. 2 would be the distance between the cluster head 1 and the particular point, as well as 90 would be the distance between the cluster head 2 as well as the particular point. And finding out the index of the minimum value would allow us to find out that this point is similar or close to that particular cluster head. By finding out the index, we'll be able to push it to that particular key in the classes variable. So I have appended or pushed the point to that dictionary using classes. Min_dist inx is the index of the minimum distance, and since the key value pairs is gonna be in a format that the keys would be the index of the cluster heads and the values would be the lists. In order to push the values into the list, we'll be using the method append. So I'm appending every data points which are closer to the particular cluster head in this statement. And coming to the main and the major step of our algorithm is computing and updating our centroids or cluster heads. In our example, the cluster heads or the updated new centroids will be computed by finding the average or the mean among the data points of the particular cluster. So if you are going to find out the new cluster head for the red class or the cluster seed or the cluster 2, we'll be finding the mean of all the features. So the similar method I have applied here in code. So the np.average method will be able to compute the average of every particular feature. So the axis equals 0 would denote at in what dimension that the averages must be calculated. If we are defining it as axis equals 0, then the average will be computed for every dimension or every features. And the .toList method, I've used .toList method in order to convert the NumPy array to a list variable so that I will be able to do the list comparison. And inside I have declared a loop because since we have three clusters, we need to be figuring out the new clusters or the updated clusters for of cluster heads for every clusters. So I need to apply that np.average method for every clusters that we have declared so far. So I have iterated inside. So the new cluster heads list will have a nested list with each element containing the new centroids or updated centroids. The format in which new cluster heads would have is so this is the output of new cluster heads. So every element or every list in the particular nested list would correspond to the centroid or the new cluster head. And coming to the checking part or the conditional part, this cluster heads same. As mentioned above in our method, def is clustered if cluster heads same, that method will enable us to figure out whether the current generated clusters, which is the new cluster heads, is it same to the old cluster heads that we have used so far. So it returns a boolean value. So if it is true, then we could actually say that okay, the cluster head seems to be repeated. If it is false, then it will be then there is some updations going on. So we need to iterate it once again. So let us say that the cluster heads remains to be same. If it remains to be same, then we need to come out of the loop and we need to finalize our entire clusters. If not, we need to iterate it once again. So the new cluster heads would be copied to the previous cluster heads. So the centroids or the cluster heads or the seeds which are generated at every iteration would be copied to the previous in order to compare it with the coming or updated cluster heads. So I'm copying the new cluster heads variable to the cluster heads. And I'm also declaring a colors dictionary, which is once again a key value pair. The key would be the index and the value would be a string. So the strings would be the name of the colors that I need to use to identify or visualize the plots. So as I mentioned earlier, the classes dictionary is going to play an important role in our code. So every keys is going to be the index which denotes the cluster heads or for which cluster does it belong to. So similar here as well. 0 would denote the cluster 1, 1 would denote the cluster 2, and 2 will denote the cluster, the third cluster as well. And coming to the visualization part, in order to understand how does our algorithm learn and how does it forms clusters at every iteration, so we'll be able to understand it visually. So I have created a loop in order to iterate through clusters. So as the method that we have declared earlier, which is plot data, we will be sending it according to the clusters or according to the cluster heads and along with the colors that it needs to be represented. So I have used plot.title method in order to name every graph. Plot.show in order to display or in order to show the visualization or the plots that have been made until now. And I have incremented the iterations value. So now let us just try to run the code. So it is done. So this is the first iteration. So which is so this is the image of the first iteration. In our first iteration, the number of cluster heads that will be generated will be randomly initialized, as mentioned earlier. So we can see here that the red cluster head seems to be among yellow, and the yellow one seems to belong along the green, and the green belongs to the red. So so we could say that the model is not pretty much working, or since it is at the initial step, we can actually figure it out at the next iteration after updating the cluster heads. We can see that the cluster head seems to be changing upon a bit. At the third iteration, we could see the final model. We could see that the green has been grouped and the cluster head seems to be perfectly aligned as well. The yellow seems to be perfectly aligned as well as the red seems to be perfectly aligned. But actually, while we iterate and we see at every iteration how the algorithm works, we can see that how the data points and cluster heads seems to be changing its position at every iteration, that we can actually visually see it here. And yeah. So coming to the recap of what is K-means and what is how does it work. So K-means is a clustering algorithm, which is which primarily works upon data sets of mainly it is an unsupervised learning algorithm. The K denotes the number of partitions or number of clusters that needs to be created, and a reference point or the cluster heads that needs to be created or that we'll be using for learning purposes is known as a centroid or a seed. So the initial step would be randomly generating the K or the number of clusters, and we'll be randomly selecting the cluster heads or the cluster seeds. We'll be finding out the distances between every points, between the every data point as well as between every cluster center. And we'll be assigning every data point to that cluster based on the distances that has been computed, as well as we'll be updating our cluster heads by taking the mean of the features or attributes of that corresponding cluster. So here you go with K-means algorithm. And as discussed about iteration and convergence criteria, we could actually converge it based on like if the clusters do not change, and we could or we could actually set up the number of iterations that we have declared so far. So Here we go with the first session, and in our second session, we will be in our the upcoming sessions. We will be discussing in depth about feature engineering and how these methods could be applied as well. So this is a QR code. So if there are any queries or if there are any questions to be answered, you could actually scan this. This belongs to my URL of my LinkedIn profile. So you could connect to me and you could ask me at any time. Yeah. So and once again, thanks a lot for the Azure community in order to provide me this opportunity as well. And thanks once again.
Yeah, thanks, Ashwin, for providing a wonderful session on the feature engineering aspect of unsupervised learning with respect to K-means algorithm. So let me check any questions the participants are having. So we will be posting multiple session in the upcoming days. So please watch our Azure Developer Community Chennai meetup group for further details, as well as we are hosting the faster hackathon from Microsoft at Microsoft Chennai office. You can nominate for the hackathon as well. So the hackathon link has been shared on the same YouTube channel. For more information, you can watch our YouTube channel. And if you are want to participate in our community event, feel free to reach out to Navanithan Gopal. He's our organizer of the Azure Developer Community Group, Chennai. And you can see our Azure Developer Community Chennai page in the meetup as well. And we will provide more sessions on the artificial intelligence topic, machine learning, the developer series, as well as sustainability series. So all the type of series are there, and we are running the this is a meetup program which is running on that webinar, as well as online event will be there, as well as in person event will be there. So for more details, please watch our community group which is there in the meetup.com, as well as any queries you can always feel free to post on the LinkedIn community, as well as you can post it in the YouTube community as well. So we will help you to answer for any more questions. So thanks for joining and thanks for time you all, and we will meet in some other series in the upcoming days. So thanks everyone.